Assalamu alaikum. This is the next part of the video regarding matrices chapter, and here we are going to describe the types and explanation inshallah ta'ala will be given to you of different various types of matrices. So let's begin. In the very first type we will discuss about the row matrix. A row matrix is called a row matrix. Why? Because if it has only one row, for example, if I have a matrix M equals to 2, -1 and 7. I've already discussed in the last video that these are the brackets which are specifically used for matrices. The entries are enclosed within these brackets, and these brackets are known as our matrix. This is the identity of our matrix. So this is our matrix M, and it has one row. The horizontal ones are the rows, and the vertical ones are our column. I would like to request you that if you haven't gone through with my previous video, which was based on the basics of matrix, please go through with it so that you can revise all the previous initial basic work so that you can understand it better. Here I am discussing the row matrix. I have already told you that it contain only one row. Now if you see the order is, rows are, how many rows you can see? One row by 3 column. So now next move on to the columns matrix. Column matrix, as you can understand from the first row matrix definition, you can guess the idea that it must contain only one column. If n equals to 1, 0, so you can see it has two of the rows but it has only one column. So this is C1. So the order would be 2 by 1. Easy. Now next move on to rectangular matrix. What a rectangular matrix is, let me tell you. Well, rectangular matrix is a matrix if the number of rows of this M matrix is not equal to the number of column, then it will be a rectangular matrix. Like if we say let consider B is a matrix of having A, B, C, D, E and F entries or elements. So it has how many rows? You can see 2 rows, and column 1, column 2, column 3. So here the order is not equal, 3 of the columns and 2 of the rows, right? Similarly, if I take another matrix C, it has 7, 8, 0 as the entries, and here the rows are 3 and columns is only 1. So you can see the order is not equal. Rows are 3 by 1. So this is also known as the rectangular matrix. Now talk about the square matrix. A square matrix is a matrix in which its number of rows is equal to the number of columns. Square matrix. Let's have an example. Let consider B as a matrix with 1, 2, 3, -1, 0, -2, 0, 1 and 3. So you can see 1, 2, 3, these are the rows and these are the columns, C1, C2, C3. So order is 3 by 3. So the order is equal. Number of rows is equals to the number of columns. Next is null matrix. These are the simple and easiest types. Therefore, I am not taking too much time in describing all of them. I am just giving you the quick review with the definition and example, and I hope that it will be enough for you. Null matrix having all the entries equals to 0. Let's consider matrix A. If you have this 0 and 0, or you can say the matrix is 0 0 0, or if you consider this as well, 0 0 0 0 0 0, and last one as well, all the zeros entries. So here the order is 2 by 1, 2 by 2, 3 by 3. So but the entries, you can see all are empty or all are zeros. So this matrix is known as null or zero matrix. Now let's talk about the transpose of a matrix. A matrix obtained by changing the rows into columns or columns into the rows of a matrix is called the transpose of that matrix. If A is a matrix, then its transpose is denoted by A raised to the power t. You can call it like this. Let's suppose, let's consider a matrix. Over here, A is equals to 1 0 2 minus 2 minus 1 and 3. This is my matrix with having 2 rows and 3 columns, right? So if I'm putting a transpose on it, I'm applying the transpose, so it will be changed into the rows will become the column. So this will be, this all entries will be changed as the column. So 1 0 2 will be written as 1 0 2, column changed. Now next row will be minus 2 minus 1 3, so it will be written as minus 2 minus 1 3. Okay, the transpose of this matrix has been done. Once I have applied the transpose on the normal simple matrix, it was in the form of rows and columns, but now you can see that it has 2 of the rows, 2 of the columns and 3 of the rows. Okay. Another example for the transpose, I don't want you to be confused. Let C is equals to be CO, that means 0 and 1. Now I am putting a transpose on it, so it will be 0 first and 1 down. Okay, the rows has become in the form of columns. Now going to next, which is negative of a matrix. Negative of matrix. Let A be a matrix, then its negative minus A is obtained by changing the sign of the entries of A. It's simple. If A is equals to 1 minus 2 3 and 4, so it will be minus A. कैसे होगा? Minus A will be, all the positive entries will become the negative and the negative will become the positive. So these are the positive, I will write it with the minus sign, sign of negativity, it is with the negative sign, so it will be positive. 4 is positive, so it will be negative. Answer, this is my negative of a matrix. Easy. Okay, symmetric matrix. What are symmetric matrix, by the way? They are the matrix if it is equal to its transpose. A square matrix is symmetric if it is equal to its transpose. Let's consider a square matrix. The rows and the columns, the order is equal. So 3 rows by 3 columns, right? It is a square matrix. We have already learnt the square matrix. So taking a square matrix, what I am going to do is to take the transpose. It must be, after taking the transpose, it must be equal to the previous image or position, that is A is equals to this one. If they are equal, then it will be the symmetrics. It will be called as symmetric matrix. So I am taking a transpose. The column will become the row. This column now 2 minus 1 4. 2 minus 1 4. Now 3 4 0. I will write 3 4 and 0. So let's check. 1 2 3 1 2 3. 2 minus 1 4. 2 minus 1 4. 3 4 0. 3 4 0. So it is same again. So A is equals to the A of transpose. So that means that the matrix are This matrix is symmetric. Let's talk about the skew symmetric. Skew symmetrics are those matrices when we consider a square matrix and then taking the transpose of that matrix, the answer equals to negative of the matrix. That is a skew matrix. That means if we consider A as a matrix, then take a transpose, then the transpose will be equals to negative of A, then it is said to be a skew symmetric matrix. Now let's consider A equals to 0 to 3, right? Minus 2, minus 3, 0, minus 1, 1, 0. Now applying a transpose, A transpose, changing the rows into columns, 0 to 3, minus 2, 0 and 1, then minus 3, minus 1 and 0. Now let's check. Negative of A, 0, that entry was, these two entries were in the positive form, so they become negative. Negative, negative become positive, 0 and alternate. 1 was positive, so it is negative. Now 0 is neutral. So we have got minus of A. That means A transpose is equals to negative of A. The matrix is skew symmetric. Now if we talk about diagonal matrix, a square matrix A is called a diagonal matrix if at least any one of the entries of diagonal is not 0 and non-diagonal entries are zeros. How? Just consider this matrix A equals to a square matrix. That means the rows and the columns will be same, order will be same. Square matrix A is called a diagonal matrix if at least one of the entries in the diagonal is not 0. One of the diagonal non-zero entries are here and the remaining other than the diagonal are all zeros, right? So this is the diagonal matrix, okay, of order 3 by 3. Now next is if you consider M equals to 0, 2, 0 and 0, 3. Now here I am considering 2, 0 and 0, 3. So other than the diagonal is entry other than 0, okay? So diagonals in the diagonals other than the 0 entries and the rest remaining diagonals are zeros. So this is the order 2 by 2. That's the order was 2 by 3 by 3, okay? Now scalar matrix. The diagonal matrix is called a scalar matrix if all the diagonal entries are same. How? Now look, diagonal entries are same. If we consider this, now remaining are zeros, put the zeros on the other remaining entries, okay? So here we have the diagonals are the entries which have same numbers or non-zero numbers. You can consider this B equals to 3, 0, 0, 3 for your information, okay? Okay, we have the identity matrix. A diagonal matrix is called identity or unit matrix if all diagonal entries are 1 and is denoted by I. So identity क्या होती है? We have the matrix over here 1, 0, 0, 0, 1, 0 and 0, 0, 1. So this is the order 3 by 3 and here the diagonal is called the identity matrix or unit matrix because all the diagonal entries are 1. So this is also identity matrix also denoted by capital I like this. So these are all the kinds we have already learned and I have explained to you. Then we are going to do the addition and subtraction inshallah ta'ala and multiplication in the next video. Then we have some laws, and then we will be covering inshallah ta'ala the adjoint, the determinant, the additive identity. The next is your inverse. Then we have multiplicative inverse. Then we have the transpose in detail. Then Cramer's rules, and the last one is after Cramer rule we have inversion method. Okay, so that would be covering all the topic of our matrix inshallah ta'ala, and I will explain it to you with examples and definitions. Till then, inshallah ta'ala, we will meet with the next video. Leave your comment if you don't have any if you don't understood any of the concept, or you got any of the difficulty, you can leave a message. I will sort it out inshallah ta'ala in the next video. Allah Hafiz.